It's still f of x equals x squared. However, we're rotating about the y-axis. Okay. So what's your setup going to look like as far as your parametric equations go? So x equals t and y equals t squared. All right. It's never a bad idea when you're rotating something to graph it. And you guys know that from what we did with solids of rotation. And this guy is pretty easy to graph. It's a parabola, but I only need the right half of it, don't I? So we're going from the point 0, 0 to the point, so this is rad 2 right here, radical 2, comma 2. And we want to find the surface area when we rotate this about the y-axis. So what's R going to look like? Well, if you draw in a representative trapezoid, which you don't really need, you just need a horizontal line there. You could think of R as, you know, the average length, average long length of that trapezoid, right? And so what would that be? What kind of value would it? Now, okay, this gets if you're not careful here, you could mess this up. That's a horizontal distance, right? An x value, isn't it? So what does it have to be? T. Can you see how easy that would be to mess up if you're just in a hurry and you're not thinking about it? So that distance for R, let me actually call it R. So it's clear. R equals T. Because it's an x value and x is t. Does that make sense? Okay. Okay, so then you're good. We know we need to find what? Derivatives. Dx dt? 1, and dy dt? 2t. So remember what the formula looks like. The integral for area, capital S, okay, 2 pi out in front, right? 2 pi r L, or 2 pi r ds. But if you sum them all together, you got to have an integral in between, right? And then, so what's the r? T, right? And then the ds. Everybody see how I got those? And then what do I need on the end? dt. What are the bounds? Is this in it? Okay, now this is where it gets a little confusing. You see that horizontal trapezoid and you're thinking it's an integral with respect to y. Is it? Well, x equals t. It's an integral with respect to x, you guys. So you have to you have to think, what's the low on the t, what's the high on the t if you're integrating with respect to x? 0 to rad 2. But if you reason it out like that, you can do it. Now, the answer here turns out to be something a little different, at least. 13 pi over 3. Let me make sure I'm giving you the right one. I am. Is that a tough U substitution? No, you're going to let U equal 1 plus 4t squared again. Now, what I haven't done is I haven't shown you, okay, the other way around, right? When you're dealing with x as a function of y, and you let y equal t. There's another way to do this problem. So this is the same as saying y equals x squared, right? Well, if you take the square root of both sides, you can think of it as x equals, we're only interested in the positive square root of y. And then you could actually set it up the other way. You could say, oh, let y equal t, right? And then what does x equal? Root t. So if you go ahead and take the derivatives real quick, what would they be? Dx dt 1/2 t to the negative 1/2. And dy dt, 1. And since y equals t, this integral is actually going to be with respect to y, isn't it? So when we set it up then, we integrate now. Okay, what does r turn into? What is x with this one? So this is for the second one. It's the square root of t. Do you see how it changes? Or r equals the square root of t. And then the 2 pi on the outside. But it's an integral with respect to y, so what are the limits on the integral? 0 to 2. So that actually made a little, at least easier on the eyes, an upper limit of integration. However, what happens when you plug into the ds, the square root of dx dt squared plus dy dt squared? Okay, the 1 part's easy. You square 1, you get 1. But then this guy right here is really, 1 over 2 radical t, isn't it? And so you square that guy, and what do you get? 1 over 4t. So it's a little uglier on the inside. But so now I did show you how to set it up if you had x equals a function of y. That would do it. And you'll get the same answer. Which one would you rather integrate? I'd rather integrate the first one. But, I mean, you could do it. Oh, and by the way, the r is uglier too, right? The square root of t versus just t. So I'd rather do it the first way.